uh, using the potentiometer to compare to EMF of two cells, to compare EMF of two cells, E1 and E2. That points, so what they do is they connect first 1 and 3. 1 and 3 are connected. So if they are connected, so this is not connected E2, and you will get a balance point somewhere. That means he's taking it to be N1. Now, why this balance point happens? Because of this battery, see the terminal. This is the driving battery. This is the other. So this is passing a current through this. It goes like this and goes like this, and what happens is that it causes a drop, a resistance. The resistance here causes a potential drop. This potential drop per unit length is then is like supposing is from this point we measure. So this is L. This is L1, and this L1 into this potential drop. So if you got a null point here, that means the potential drop here and the potential, because of this, they are creating are equal. Because you see, if there are two cells, if there are two cells and they are of equal this thing, so the potential drop here and here of both the cells is same. So no current will flow. 3 and 3 supposing. So that means the potential drop in this is this. Now, how do you get that? Well, you first say that what's the current flowing. So you know the resistance of this. So R you know, and you know the potential of this. Let's say it's B, and then you get the current, and then you multiply it by the resistance of this, and then you can that will be the potential drop across this wire from here to here, and then per unit length you divide. So that's what he does here. You see, he's first you is not explained it here, but the thing is, first you find the current. First you find the current I. After you do this, then you multiply it by the resistance of the this wire. This wire, supposing it starts from here. This they have not drawn it properly. Supposing it starts from here to here, and then you know the total potential. You know the resistance of this wire from here to here, and then you say, okay, I know the resistance. I multiplied by the current. This is the potential drop. Then you say, let's say 100 centimeter is giving you this. So what is once per centimeter? What's the drop? So phi is that. Whatever is this drop divided by 100. So per centimeter. And then you multiply by the length where it balancing. That means this is the potential drop at till L1. Similarly, this is the potential drop in. So these two batteries each will give up different null point because they are of different values. It's like this two batteries who are putting pressure, one from this side. This is E1, and the driving battery here, which is causing a potential drop across the L1 length in one case, and across the, so it's like two pressures, two water flowing, and one trying to flow from here water. So if they are equal pressure difference, the water won't flow, it will stop. So this is what is happening. And then you divide and you can compare. So this helps you compare EMF. This is the only way you can compare EMF of two cells, because if one is known, the other can be found out. Because you see, EMF can't be found out with any other voltmeter, because either current is flowing here, there's no current flowing. EMF can only be found. Otherwise, you get the potential difference across the battery. Only when the current is not flowing, you can get the EMF. This method can also be used to find the internal resistance. I'll tell you how.